you can see the fuel cells to be fitted in the vehicles. And these fuel cells basically what you can put some input to it is hydrogen, and that fuel cells has now generating the electricity. This electricity later been stored in the battery, and then you can drive a motor, and that is how the car is been running. The best example of this is Toyota uh, uh, Mirai is the vehicle which is in the market today, that has been commercialized. So mostly Japanese people are working on this type of hybrid vehicles. And in the future, like you will see a mix of vehicles, BEV and FCEV. I mean, the battery electric vehicles and fuel cell electric vehicles mixed one. You could see on the roads of the on the Indian roads. There is another vehicle which is plug-in hybrid. So what is plug-in hybrid is this is like switch mode, a dual mode basically. So in this IC engine also present in the vehicle, and a battery and motor is also present over there. So when you're driving, actually, you may feel the experience of EVs, or you may switch to IC engine based drivetrain also. So both the drivetrains either are possible, not both are simultaneously working. So this is called plug-in hybrid. So this is another type of hybrid vehicle that is present in the market today, and Mitsubishi Outlander is one of the example of that. So in this, like if you are going with some type of suppose you're starting from A location to B location, and in between, suppose your battery discharges. In that, you may switch to IC engine based thing, and that is how it has been working, right? So this is plug-in type of hybrid vehicle. There are other vehicles, which is Toyota Camry, which is called as fully electric vehicle. So in this, there are basically two types, in which either you can generate your electricity from engine. So engine actually produces a shaft work. It generates some electricity, and later it is being stored in a battery, and battery is converted through that, and like electric motor is run through that. So this is series type of hybrid things. There is parallel type of also possible. There is an engine which gives power up to the differential and then wheels. So this is one way possible. Other way is parallelly, you can have battery, then converted an electric motor. So either you can switch to completely engine based or battery based, or you can have 50% engine and 50% battery also. So both, the whole vehicle is being powered by both battery and engine, and that is possible in the Toyota Camry, which is fully commercialized today, and that is called as fully electric vehicle. There is mild hybrid vehicles are also possible that today we are using basically. So IC engine, which are running through the use of petrol and diesel, and then this is being connected to alternator. A little amount of electric energy is being generated through that, and that is charging the battery. And this battery is utilized for running the appliances and interiors of the vehicle. Like you can see that the air conditions and all. So this is possible, right? So these are the different electric vehicles possible and been commercialized in the globally. There is so like the major topic that we are discussing today is need of electric vehicles. So why we need to shift from IC engine vehicles to EV based vehicles. The most important thing that we can see is EVs are actually having very sophisticated technology. It has very less weight. EVs are easily made smarter. I mean, like you can put some stuff like IoT based things, some stuff like energy saving things in this particular. So energy saving things can be programmed in this through electronics control systems and all. So it can be made smarter compared to IC engine based vehicles. Its running cost is very less. I mean, if I say about like any particular four-wheeler that you take, it generally costs with today's fuel prices to 6 to 7 rupees per kilometer. But EVs are possible in few paisas. I mean, like just few paisa, 90 paisa, 80 paisa or something per kilometer. So that is possible today, right? It has a less maintenance part because there is no huge gearbox requirement. So that is the most important thing. And that's why EVs are actually this simple construction. Today, what we can see in this particular picture is this is the smallest gearbox, where are like only two-step gear reduction is there. So a battery and then gearbox. A small gearbox ultimately reduces the maintenance cost of it. There is a less gear failures, less bearing. So total rotating part totally reduces. So if we compare with the IC engine vehicle, there are a lot of gears possible. There are four, I mean, like step gearbox is there. And that's why first gear, second gear, and then third gear and last gear. And that is how the total rotating part increases. As the total rotating part increases, there is a lot of maintenance is possible. And just because of there is a IC engine attached to that, to the IC engine based vehicles, a lot of maintenance comes over there. On the other hand, again, electric vehicles are very smooth in operation. They are very quiet. They are not producing a lot of heat. They are not producing a lot of vibrations associated. And that's why electric vehicles are the first preference today. And most important, if I tell you why we are going for it, is pollution free. The EVs are very pollution free, zero emissions over there. If you just take a look at this particular chart, the transportation emissions due to the transportation is almost 29% globally. This is actually US greenhouse gases which has been emitted due to so many reasons, but 29% is being contributed by transportation vehicles. The electricity generation, it is almost 27% of total emission has been contributed. There are industries, chemical industries and like process industry who are actually generating greenhouse gases like carbon monoxides and all, and SOx and like CO2 and all. So this is being generated, and industries are contributing 22%, and remaining like commercial and residential is 12%, and agriculture 10%. This figure near about, though these figures are been of US government, but India has no exception for that. Almost similar numbers you can see or expect from India also. And that's why we need to shift because transport is a major contributor in that. That's why we are shifting. This is the major reason why we are transforming from IC engine-based vehicles to electric vehicle-based vehicles, right? If I talk about again the powertrain, uh, uh, electric vehicles are actually a smart power generators. And if you just see the IC engine-based graph, normally in IC engine, if you increase your RPM, at certain RPM, you may see that torque has increased and power has increased. So there are only few areas or few speeds at which you are getting torque, higher torque and higher power. But this doesn't happen with the electric vehicles. Generally, electric wheel drives, you may see that torque is very constant in a slower speeds. Then later it is reducing. In terms of power, if I talk, it is linearly increasing as your speed is increasing, and the curve is almost flat at all levels. So this graph is of Tesla motors, which is like a very starting movement of electric vehicle transformation what Tesla has started. So this graph is of Tesla vehicle, and and mostly you can see this transformation to every vehicles now, and that's why people are referring to EVs just because of they have initial good torque and a flat torque at power level also. And that means you don't have to wait for that higher speed to occur in the EVs. At any speed or initial torque also in the EVs, you'll get a better torque at this stage. And that's the beauty of electric vehicles. At the other end, for IC engine base, you need to wait for that torque to retain, and you need to increase the speed, and they will get a better torque, better power over here. Okay, so these are the few reasons why we are shifting to electric vehicles from IC engine vehicles. And this is a comparison with IC engine vehicles again. There are 24 moving parts are there in the electric vehicles. On the other hand, there are 150 moving parts are there in the IC engine based vehicles. And you can see if there are too many rotating parts, a lot of initial energy is actually consumed in rotating that. That is called as inertial energy. And that inertial energy is being stored in these moving parts. And again, more the moving parts, more the maintenance is required, right? There are 11 wearing parts are there in the electric vehicles. On the other hand, in the IC engine-based vehicle, there are only 24 parts are there, which is required a maintenance basically, which are going for wearing part. You can see the wearing part to be bearing or gear or something else, and that's why you need to look into these particular figures. In EVs, you could see higher torque at low RPM. In IC engine, that's why we just saw that high torque at very specific RPM range that you can see in the case of high IC engine based vehicles. Battery to wheel efficiency is almost 80 to 90%. that is continuously increasing day by day, because a lot many research is going on in this particular area. On the other hand, in IC engine vehicles, only 25% of the wheel efficiency is there. I mean, whatever you are producing through the engine, I mean, whatever you're producing, the energy through burning the fuel by the engine to a powertrain is just 25%. You can see that most of the heat is being generated in the IC engine vehicles, and that heat is being liberated, and that is not being conquered actually. We cannot converting that heat energy into something else. People have tried a lot of technology, but cost is increasing, and that's why today the technology is limited just because of cost factor, right? And you may see that a lot of efforts are being put to reduce the emissions in the IC engine vehicles today. But we need to forget the story of IC engines now. We have to think of electric vehicles. There are challenges also in this particular field. I will tell you one by one again. But today, just look at the Indian market today. If you just focus on two-wheelers and three-wheelers in India, India will grow faster in this particular area. About only 1% of total vehicles is been contributed by EVs now. I mean, like total only 1% is being sold today. So electrification, in other words, I can say electrification happened to be only 1% or less than 1% in India. If I talk globally, actually, global market says China is rapidly going faster, but Norway is a country who has 90% electrification is already done, right? Norway has been followed by California and then Sweden and so on. China is just 3.3%, and they're transforming very faster rate. This is the data of 2020 and 2021. But basically, you need to take into look that if China, if you see, if you look, we say that China is growing very faster in the transformation of IC engine based vehicle to EVs. It is just 3.3%, and India is less than 1%. So if you just look at the global scenario, there is a huge transformation is happening in every country. Every company is now putting their effort to bring their IC engine vehicles converted into EVs today. They're completely stopping the investment into IC engine based vehicles. Today, we see that if you just survey the Indian scenario over here, most of the people are using two-wheelers, right? Almost 81% of the people are using two-wheelers. There are 13% people are using four-wheelers, 4% are using trucks and heavy vehicles. Only 3% are using tri-wheelers in India. So if you just look at these two figures, 81% by two-wheelers and 3% of three-wheelers, combined effect, you may think of that two-wheelers and three-wheelers is very easy to transform because the battery requirement for these two vehicles, two-wheel and three-wheel vehicles is very less. So battery requirement is less, size is less. That's why we can go further. Unfortunately, India doesn't have lithium-ion based batteries raw material. Lithium-ion based battery requirement of the lithium-ion battery requirement is lithium-ion metals. For that, the ore of that, I mean raw material, we don't have in India. It is abundantly available in China and so many other countries. So what India is trying, India doesn't have these sources, so India is trying with other small countries. They are having good MOUs, good tie-ups with them now, and we are importing that lithium to India. And now the companies like Maruti Udyog and all, they have started developing our own batteries today in India, right? We are developing the cells, then we are assembling that. See, manufacturing of the cells and assembling that is totally different. Cell manufacturing required a lot of chemistry, a lot of technology involved in that. Assembling the cells is very easy today. So what we see today's batteries in EVs are basically series and parallel of the batteries, cells basically. Those are arranged series and parallel. And then those are being used in the vehicles. So India is likely to see almost 3 million plus EV cells by the end of 2025 with the cheaper batteries and right policies by the government. And significantly, people are adapting that. People are purchasing electric bicycles, electric bikes, three-wheelers and all, because they could see the transformation. They could see that how efficient the EVs are actually, right? Where is like that 5 to 7 rupees per kilometer, and where is like 90 paisa per kilometer. So that is a huge difference, right? The electric vehicle industry in India is not far behind. Basically, it is increasing tremendously. I mean, government is putting a lot of policies. I will also discuss the policies regarding that. Charging infrastructure is today it is very slow, but it is definitely increasing. But it's like is why charging infrastructure is not increasing today? It's just because of we don't have EVs, and both are actually countering to each other. More number of electric vehicles will come on the roads. Charging infrastructure will simultaneously increase. It's like which came first? Is it egg came first or is it a chicken came first? So that is how the story is moving about. Okay. So Indian overview, I told you like it is increasing. A lot of opportunities are there in India. Like we could invest. A lot of people are investing. I mean, not only engineering people who are not of the engineering background but businessmen. They're putting their money to invest in charging infrastructure structures. They're developing. They're contributing into the indirectly generating the electricity and putting into the grid or something. So this is what actually happening. Simultaneously, one thing we need to take care of, as electric vehicles require electricity to charge their batteries, the electricity should also be generated simultaneously at higher level, because load on grid will definitely increase. And that's why government is also thinking of increasing the or meeting the demand of electricity by putting a lot of investment in non-conventional energy sources. Like you can expect in the near future that you'll see solar panel based electricity, tidal energy and all, windmills and all. So this is non-conventional energy sources. Why we are focusing on non-conventional energy sources, though their initial cost is high, is just because of in generation of electricity today in India, 70% of the total energy generated in India is by using a raw material which is coal. So we are importing the coal. We have the coal mines in India, and we are burning those coals to generate the electricity. So actually, we are contributing or we are increasing the CO level or CO2 level in the environment by burning the coal to generate the electricity. So ultimately, our aim is to protect or support the climate change, right? So if the climate change is happening, we should put two things together simultaneously. One is generation of electricity through renewable energy sources, and second thing, second thing is promoting the electric vehicles at a faster rate. And that's why government is putting a lot of effort to end-to-end customers also, and at OEM levels. I mean the manufacturer level also, right? Let's see the next slide. What different government policies have been promoted. So government policies have been promoted at different levels. We have different schemes like FAME second, CAFE, and then GST and taxation incentives and PMP schemes are there. So these are the different schemes what government is putting. These schemes at GST level or something. See, like if you are purchasing a vehicle today, it has more GST today for IC engine, but for electric vehicle it is just 5%. So at GST level also, government is putting a lot of efforts to reduce the cost of the vehicle so that people may get interested in purchasing the EVs, right? At battery level also, we are importing from Bolivia. Bolivia is the country like China, because China is not a good political supporter of India or something. So that's why it's very difficult. We are importing the batteries from China today, but China is not giving us the raw material, which is lithium. The lithium metal is being imported from Bolivia, which is near to China, and
अनम्यूट झालाय सर. हॅलो.
yeah, I guess
Okay, okay.
somebody like is automatically getting muted. I don't
Yes,
know.
yes, 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 sir. Okay.
Anyway, so electric vehicle battery, government is putting a lot of policies, a lot of pressure on it at customer level also, at manufacturer level also. Okay. Second thing is grid generation. So we are developing continuously. I told you like we are generating a lot of electricity simultaneously. A lot of government is putting their effort in generation of electricity using non-renewable renewable energy sources. where and simultaneously they are also developing the charging stations, charging infrastructure. Today you see that if like people are thinking like why to purchase an electric vehicle, initial cost is little high, though the operating cost is less. And there is another point that no charging station is available. If I'm starting from Islampur to Pune, there is 200 kilometers away from here. I have to take a pause and I have to charge my battery, right? And for that, there is no charging infrastructure available in between. There is no charging point available. So government, what they're putting is they're promoting the charging infrastructure investors, right, to have localized charging stations available. All the fuel uh, fuel generator company, I will say, fuel processing companies like Indian Oil Industry, Indian Oil. There is private partners like uh, Reliance and all, or Bharat Petroleum and all. So they have their own uh, fuel filling stations are already available. Fuel stations are already available. So what government is trying, along with the fuel stations, these companies will also invest in charging stations. So charging infrastructure will get developed accordingly. Okay. There are OEMs which are coming in the front. Uh, like Tata Motors, if I give an example, Tata Motors is developing their own vehicles, and Tata Motors is also developing their charging stations. So you could see in the near future that they will give incentives to Tata vehicles in a more way. So in like European countries or US countries, they have Tesla Motors, and you can charge your Tesla vehicles on Tesla charging stations only at free of cost. And that's a good promotional points or policies what companies are also putting out. And that is how, like, if you see the two-wheeler industry in India, uh, nowhere like TVS or Honda has developed the electric vehicles 2 years back. Now they're coming in the market, but the companies like Ola and Author Energy or something, they have already developed their two-wheelers, and they were never a player as like TVS or Bajaj or Honda or Hero Honda or something. But a big players are coming at a back foot basically, but the newcomers are coming at the front, and those are investing a lot. Lot of foreign investment is also coming over there. You can see Ola, which was actually service partner basically. Now they are in the electric vehicle manufacturing. So you could expect new faces in these particular things, and that is the reason why. That is the main reason behind this is like government policies only. Okay, so if I just name few things like who are coming into this is Ather Energy and the two wheelers, then Hero Electric is there. We have Ola, we have Okinawa. These are all Indian companies. We have another Indian companies like Mahindra and then Tata Motors, which are also investing into Bajaj for three wheelers and all. Mahindra, Tata, and Hyundai, MG Hectors are investing a lot of things into four wheelers and all. There is Tata and Mahindra already there are in trucks, and electric trucks are coming in. There is Tata Motors is also always investing into buses and all. So we can see Olectra and Tata and JBM, these three companies mostly investing in India for electric buses. In Pune, you can see the already electric vehicles or electric buses already running over there. That's the beauty of that. In the near future, Delhi government and even the central government is installing about 7,000 electric buses. See what transformation will happen, because buses is something which is a mass transformation of passengers and all, and having electric buses is actually efficient compared to having individual vehicles. That's why more effort has been put actually on the electric buses also, right? Okay, so coming to feasibility of this electric vehicle, I told you like the most important part is of the electric vehicle is economy. Those are like very economical in nature. Today we see EVs have fewer moving parts, as I told you, compared to IC engines. They have very high efficiency, no thermal emissions are there. That's why environmentally also there is no energy loss is basically there, right? There is improved air quality is also there. Today, if you compare the China, the most populated city in China is their own country, their own capital itself, and that was so populated that they have pushed this electric vehicle so tremendously. Today, the emission levels is reducing in their capital. Today, India also there is a lot of policies by Delhi government has been put, even the central government, to put a lot of auto rickshaws and passenger vehicles to get transformed into this electric vehicle. So this shifting is occurring over there. People are also trying CNG-based vehicles. That is another option in reduction of these emissions. Actually, there is another things that I want to talk is convenience of electric vehicles compared to IC engine vehicles. EVs have no gears and very easy to operate. Lack of combustion and mechanical drivetrains. Comparatively, you can charge at home, you can charge at office, you can charge at like charging stations also. Upfront incentives are being given by the government today. There is incentives by government for scrapping your vehicles also, and there is a scrapping policy coming in. So government Ministry of Heavy Vehicles have put a policy that, and that will be definitely implemented in near future. The vehicle, anything it could be passenger vehicle or commercial vehicle or anything, or could be heavy vehicles. If it is like 15 years old, it could be scrapped completely, because you could see already IC engine based vehicles are running on the roads, and addition to that, EVs will come into the picture, and that's why there will be totally crowded cities will be there, and that's why the old age IC engine vehicles should get now converted to EVs either, or could be totally scrapped. So that is called as retrofitting. Converting the IC engine vehicles to EVs called as retrofitting, and that is also a good business. That we'll talk in later slides. EV owners can claim income tax reduction up to 1,50,000 under Section 80 EEB, and that is what like this is another government policy again to promote uh, purchase of EVs. So income tax reduction is also possible if you are purchasing it. Then reduce dependency on imported fuel, fossil fuels or something. So this is what like we are the number 3 country. We are importing a lot of fuels from outside. We are importing from southern Arabian countries and all, and that can be reduced completely. In that way, we could save a lot of money in importing it, right? So that's why we need to shift it. The shift is very important in this particular. Along with these things, a lot of challenges are also there. It's not easy in transforming these electric vehicles to IC engine-based vehicles. What is the difficulty in this? The cost of the battery is too high because it is contributing almost 35 to 40%. There is a lot of effort has been put to reduce the cost of it. The cost is higher because the users are less. Second thing, the cost of the lithium is so high, and so many countries don't have lithium ion sources. They don't have mines of those. Example is India. We don't have lithium ion based mines over there, but we are dependent on other countries. That's why cost of the batteries is higher in India, and just because of we are dependent on China or related countries. In near future, we are developing our own batteries today, and that will definitely promote in reducing the prices of EVs in the near future. Next 2 years, you will see that exponentially the sales of the EVs will increase, because as the sales will increase, the cost of the EVs also go down. I told you like availability of lithium and other metals, cobalt and nickel. These are the different salts have been put along with the lithium. PO4 is another potassium is another metal which has been combined with lithium to make it safe, to make it more reliable according to Indian conditions. Because lithium ion batteries are very hazardous below minus 10 degree and above 50 degrees Celsius. But lithium ferrophosphate battery, which is actually another salt, another type of battery, which are very safe below minus 10 degree, and also limit is 70 degrees Celsius, not 50 degrees Celsius for lithium ferrophosphate battery. And that's why whatever the development is going on is as per the Indian conditions. Okay. Third thing that I want to tell you is charging infrastructure, which is continuously developing in India. I told you like we are thinking of renewable energy sources. What is the difficulty in this is majority of the household in India are connected through 200 kVA transformers, which cannot handle more than 20 cars being simultaneously charged by 7.4 kilowatt ampere AC charges. So you cannot charge 20 cars simultaneously in one building, suppose. And that's the limitation, because transformer fitted into that is having limited capacity. That's why at this level also we need to put extra transformer to get charged maximum number of EVs simultaneously. So this is possible, and that has been uh, currently it is a limitation, but this problem can be solved, right? There's a conversion of existing IC engine vehicles into EVs, and retrofitting and scrap policy is actually a challenge because retrofitting 100% is not possible. And you will retrofitting will not give a new look to your vehicles, though the at transmission level everything is changing, everything you're retrofitting over there. But I don't know, like there are companies like Trio in Hyderabad or something. These companies are transforming your own IC engine vehicles into electric vehicles. That is called a retrofitting. There is a scrap policy. People are against that basically because if it is something like this own property, even if it is 15 years old, why you will think of scrapping it? Huh? There are few people who are not thinking of there is a serious issues of climate change. They're not very serious about it, and that's why they are against the scrap policy. But let's see, like the government will make it mandatory. Government people will itself come to your vehicle location and they will pick it up and then scrap it. Against that, what you are giving, government hasn't decided it, but soon the bill will be put into the Lok Sabha or Rajya Sabha so that scrap policy can be made compulsory to all over area of the India. Okay. There is another thing which is electricity generation using renewable energy sources, where Indian government is putting some effort into that. Okay. But what along with these challenges, what government is putting into is support over electric purchase. Some subsidies are being given over there. So what government is putting, suppose your IC engine vehicle is getting at suppose 10 lakhs or something, and your EV of the same kind is getting at suppose 12 lakhs. So 10 lakhs and 12 lakhs, there is a difference of 2 lakhs. So 2 lakhs will be the subsidy, will be given by the government today. It's already being given, but still it is little bit higher range. So 20%, which is actually a costly one. So at the same cost today, you would see in the next future, next 1 or 2 years, you'll see the cost of EVs will reduce drastically. You will get at the same price as IC engine. Okay. Support over electric charging stations. Currently, there is no subsidy given on charging station installation. But again, as charging station will increase, Indian government will also put some subsidies over here. Again, support to startups to push at early stage of the business. Every effort has been put for electric vehicles uh, to reduce the income tax margins, reduce the GST levels and all. That is how the government is pushing startups in the which are related to EVs for a near future, right? So this is what actually happening. Electric vehicles, some myths are there. I mean, people are talking about it. I told you like transport sector is not major contributor to emissions. That is what people think. But actually, I told you the number tells you like 29%, the highest percent is actually contributed by the transport sector. That's why, as climate change is concerned, maximum contributor is the transport sector. And what it comes is your passenger vehicles, trucks, and all heavy vehicles. That's why government is putting over there. So this is a big myth that transport sector is not contributing major in emissions concern, but a lot of effort has been put now to transport sector along with the other sectors also. So electricity generation sectors and all, right? EVs take long time to charge. So today, like people can see like 2 hours to 3 hours of charging of electric vehicles. Many companies have reduced it to 1 hour. If you have to fully charge, 1 hour will take. That is 60 minutes will take. But definitely due to a lot of technology coming into that, we could able to fast charge. And the best example is ABB smart charging technology. Today it is commercialized. Ashok Leland and ABB, these two companies partnered themselves. They had a MOU. They started working on it, and today we see superchargers and smart chargers are being developed. Smart capacitors are being developed. Those are called as super capacitors, which are actually helping in charging your vehicles in few seconds. You won't imagine that, but this is actually happening. ABB has developed that charging technology where your bus will get charged in few seconds and you can go further. Where it will be charged, where the public are actually entering into the vehicle system. So these are the bus stops. There are bus stops at every bus stops. These people, this ABB company, have developed these charging stations to the Ashok Leland buses. This is not yet started in India, but sooner or later, this technology will be commercialized in India also. Another advantage what EVs are getting is the battery pack is actually been at the bottom most part of your vehicle, and that is not the case of ICE engine. That's why center of gravity is actually reducing, and you can see this crash test of Tesla Motors. So if you see this video link, I will share this particular video link to you. Just go through the video, and you may see that due to the lowering of the CG, toppling chances of EVs is very reduced, and that's why accidental cases will also get reduced. So this is indirect benefit that you are getting. Uh, though EV's cost is too high, but I told you, like, as number of quantity increases, the cost also reduces. Today you see, like 5 years back, the 3D printers were having cost more than 2.5 lakhs. Today you can see on Amazon, like, it's just 12,500. So there's a transformation happening. So technology and patents are becoming like absolute now, and we could see in the near future that cost of the EVs will reduce. EVs have low range. That is the myth that people think, but it doesn't have low range today. You have hybrid vehicles coming into the market also, wherein if your battery gets drained, you can start your IC engine, and IC engine will charge again the batteries, and you can go for longer durations. So it will again cost you a little bit because you're running an IC engine, but there are hybridized. How much hybridization is possible? If you're going for a 50% hybridization, 20% hybridization, it depends on quantity of hybridization. If you're going for 100% hybridization, definitely you're bearing that. So if it is 90 paisa per kilometer for purely battery electric vehicles, it would cost 2 rupees per kilometer or something. But again, that is better than 7 rupees per kilometer or something. Okay. EVs are not safe. That is what people think, but that is due to the poor battery. That is the only reason for having a fire catching scenario or something on the roads. It's just due to the bad batteries. The batteries are not so properly assembled. So bad quality Chinese batteries may have the fire catching situations. But I told you, like, there are technologies coming in, the chemistry is evolving continuously. Lithium ferrophosphate batteries are very safe for Indian conditions because their range is minus 10 degrees Celsius to 70 degrees Celsius. Right? That's why EVs are batteries are evolving, and that's why will be safe now henceforth. EVs have low speed. That is another myth. But I told you, like, it has a very good speed at initial stages, good acceleration at initial because torque is good. Initial torque is good. So that's a myth which is completely wrong. Electric vehicles may have very high speed compared to IC engines. Okay, and the best example is again Tesla. Nobody have thought that sports vehicle might come could be electric vehicles. Nobody thought of that. That has been beautifully made smarter again, because Tesla is a self-driving car. You don't it sometimes don't require a driver basically. So it's a driverless sometimes. It depends on mode that you're driving on, type of vehicle again. Uh, EV batteries need to be replaced frequently. So that's the issue that today we are facing. But again, the good, if you are purchasing a good battery, it has a minimum life of 5 years. It runs at 5,000 cycles. Even in a day, suppose if you are charging and discharging, it may take 5,000 cycles. So almost like 3 years, 5 years warranty companies are giving. So there might be insurance coming into, there might be warranties coming into for batteries and all. So currently this is the issue, but in the near future that problem will, because see, we are engineers and scientists. People are continuously developing a new technology to solve this kind of problems. Okay, so this type of problem can be solved. There are not enough EV charging stations there. I told you, it's an countering part again. Whether the chicken came first or egg came first, that is the situation. If the charging stations will be abundantly available, EVs will definitely come into the market. If the EVs are coming into the market, charging stations will also come simultaneously. So these are the both things countering to each other. But these are the definitely a questions today. But this not be definitely a question in the nearer future, right? These are my few projects that I completed in RIT. The electric bicycle we have developed and commercialized. This has been sold in the market. So this is something which is developed by our RAH. This is basically RAH means RIT Alumni Advisory Hub. This has been developed this company has been developed by alumni itself. If I talk about specification of this thing, is 350 watt is a BLDC motor fitted over there. This is completely hub motor. The battery uses lithium ferrophosphate. I told you it's one of the safest battery because lithium normal battery catches the fire as it comes in contact with moistures, right? So moisture-free battery, if it is a safe battery. And lithium ferrophosphate, even if the moisture comes in contact with that, even if you drill it, even if it is went to the accident or something, this is very safest battery. It is 36 volt and 12 ampere hour battery, so that's why its range is 30 kilometers. So once you charge it, the bicycle may go for 30 kilometers. The maximum speed is almost 40 kilometers per hour. But government has limited it by for a bicycle. If it is 250 watt and 25 kilometer per hour, you don't have to register to ARA. You don't have required a number plate or something because accidental situations will definitely come down. And that's why if you are developing a bicycle on your own, take a 250 watt battery uh, and speed you limit up to 20 kilometer per hour. You can limit it to 20 kilometer per hour. Okay. There is another project that what I have developed for Krishna Institute of Medical Science is electrically powered stretcher trolley, and it was like 2.5 kilowatt, 48 volt battery, 80 ampere hour battery. So this was like two-wheeler thing, and because this is customized for Krishna Institute of Medical Science, they have the hospitals have good ramps about like 20-degree slope is there, and for them we have developed this electrically powered stretcher trolleys. This is again in the verge of commercialization. Lastly, I will say what are the different opportunities are present in this particular field. You can tap the opportunity in the two fields, basically hardware and software. As hardware is concerned, you can design, develop mechanical systems. You can go to the as a job holder, as a businessman. You may think of designing, developing the parts, and supplying to OEMs. You may get placed to OEM also. You could develop the same work over there, and you could assemble the battery. You can manufacture a motor, BLDC motors, AC synchronous motors, and all. You can develop your own controller also. So here is the hardware part. What comes in software part is data science, IoT based things, smart energy saver things, and energy efficiency systems are there, which is actually possible in EVs compared to IC engines. There are core areas are there. You can think of mechanical engineering, power electronics, embedded system, data science, software development part is also there. You can think of this also. Okay. There are certain other things are also there. Business opportunities, EVs, like what you can think of this. You can have your own business. You can develop two-wheelers, three-wheelers. Mostly you can initiate with this, or you can have. You can think of like what I thought of is electric bicycle also. EV charging stations are also possible. You can purchase EV charging infrastructure at your own place in your own colleges for bicycles and two-wheelers. You can think of also retrofitting things. You can convert your own bicycle. You can convert your own IC engine-based vehicles into EV vehicle. So ARI is the company in Pune who is regulating some kits. So these regulated kits, who has a green signal, you can purchase it. You may see the kits on website of ARI. You may purchase it and retrofit your own vehicles and convert it into EVs. You can think of having a business of repair or something, because today, because IC engine-based vehicles are getting absolute now. The mechanics will be like who are actually because maintenance is less, means the mechanic person will lost their jobs or they will lost their businesses also. You can think of opportunities. You can skill set yourself in assembling the batteries, in repairing the electric vehicles and all, right? Motor related parts, rewinding the motors and all. So this kind of business you can start with. EV parts, sales and repair, you can think of this also. And mobile charging vehicles, like basically this is like something mobile fueled vehicles are there now. The diesel and petrol will come to near to you. This is the business already going on in the market. There are companies like Repose Energy or something, they are providing diesel at your doorstep. Same way, you can have your CNG based gensets, and these gensets will produce electricity in your truck or something like big vehicle. And you may go to certain spots where a vehicle is struck due to the end of their or discharging of the whole battery or something, you may charge the battery at that particular location. So this kind of business might come into the future. You can tap that opportunity right now because you're a diploma holders. You can think of battery assembly as a good business. A lot of opportunities are you can bring the batteries from China or something, and you can assemble in series or parallel to get the required specific outcome at the end of it. Required power, required voltage, required current, required voltage or something. So this kind of business you can start with. So this is all about EVs, right? I guess this much I have. And if you have any questions, you may ask. Thank you from my side. Any questions you have, you may ask.
Hello. Hello.
Yes, sir.
Sir, my point of view, one question is there. Is geographical area or natural climate will play the major hurdle in India that EV sector is going to be enter in India? Is any problem regarding like hilly areas are there? You are saying that moisture content will play the major effect on lithium batteries. Likewise.
Okay, that's actually a vital question, an important one, because in India, temperature range is from minus 10 degrees Celsius to almost like 50 degrees Celsius, 55 degrees Celsius also is there. So if you are going to Rajasthan area, Kutch area or something else where there is a huge deserts are there you may think of having a problem related to lithium ion batteries. You may face a problem because temperature is a limitation for it. Moisture is not a big problem today because batteries are coming in a good quality. Moisture is not that big issue, but temperature is the issue. So in this case, you may prefer instead of lithium ion batteries to lithium ferrophosphate battery or related batteries, which are having combination of salts, like I told you, like ferrophosphate or something, along with the lithium. So these are very safe batteries. Okay, sir.
Okay, sir. Any students?
स्टुडंट्स मध्ये कोणाला क्वेश्चन विचारायचे आहेत का?
असेल तर हँड रेज करा. We will unmute. Okay, sir. I think स्टुडंट्सना काही क्वेश्चन्स नसावेत. It's okay. Okay. सत्यम, ask question. 1 minute, sir. सर सत्यम चौगुले.
हॅलो.
ओके, ask.
सर लिथियम इंडियामध्ये ते मॅन्युफॅक्चर होत नाही काय?
नाही, लिथियमच्या खाणी आपल्या इंडियात नाहीये, कुठंच होत नाही. आपण म्हणजे पीपल आर लाईक गव्हर्नमेंट इज इन सर्च ऑफ लिथियम रिलेटेड साल्ट्स. लिथियम इंडियामध्ये अवेलेबल नाहीये. आपण आता बुलेव्हिया वरनं लिथियम आणण्याचा प्रयत्न करतोय. चायना आपल्याला डायरेक्ट लिथियम देत नाही, तर चायनामधनं आपण बॅटरी इम्पोर्ट करतात. म्हणजे आपण ज्याही बॅटरी आता बघतो इंडियामध्ये इलेक्ट्रिक व्हेकल्समध्ये, त्या मोस्टली 80% चायनावर इम्पोर्ट, कारण चायनामध्ये त्याच्या खाणी आहेत. मग चायनाला हा ऍक्च्युली मार्केटिंग बेनिफिट मिळतोय, पण त्यांच्याकडे नॅचरली त्या अवेलेबल आहे. आणि म्हणून चायनाने पहिले त्यांच्या व्हेकल्स ट्रान्सफॉर्म करायला सुरुवात केली. इंडिया खूप लेट चाललाय त्या मानाने, पण ठीक आहे, आपण टाइमावर आहोत. म्हणजे आपलं क्लायमेट चेंज नुसार आपण वी आर इन अ राईट टाइम बेसिकली इन दिस पर्टिक्युलर. बट as your question, we don't have.
Thank you, sir.
We have a different alternatives. As I told you, sodium ion battery. If you wanted to research on this particular area, many people are also working on it. Sodium ion batteries will be a good alternative to lithium ion, though it is not that compatible. But okay, like 90% you can reach to lithium ion batteries. So याच्यावर चाललंय काम, न्यूक्लिअर बॅटरीजवर काम चाललंय. साईज आणि शेप आपण चेंज करायचा ट्राय करतोय. सिलेंड्रिकल बॅटरीज ऐवजी प्रिझमॅटिक बॅटरी आपण युज करतोय, सो दॅट टोटल शेप आपला कमी होणार. याच्यावर पण काम चाललंय बरंचसं, ठीक आहे ना. सिलेंड्रिकल कॉम्पोनंट्स मध्ये, सिलेंड्रिकल सेल्स मध्ये काय होतं की नॉर्मली एअर गॅप खूप राहतोय, आणि प्रिझमॅटिक म्हणजे चौकोनी येणार किंवा ते पेंटागोनल शेपमध्ये किंवा हेक्झागोनल शेपमध्ये आता येत आहे. त्यामुळं मधला जो स्पेस आहे दोन सेल्स मधला, तो कमी होणार. सो दॅट इज ऑल्सो गोइंग ऑन. ठीक आहे, अजून काही क्वेश्चन आहे?
हॅलो सर.
या
सर, आपण जे इलेक्ट्रिकल बायसायकल बनवतो, तर ते रिचार्ज करण्यासाठी कोणते कंपोनंट यूज करायचे बॅटरी चार्ज करण्यासाठी?
ओके, सो इफ यू आर टू चार्ज द बॅटरी, बेसिकली तुम्हाला डीसी सोर्स पाहिजे बेसिकली, ठीक आहे ना. कुठलाही 24 वोल्ट डीसी, 36 वोल्ट डीसी, 48 वोल्ट डीसी, तुम्हाला डीसी सोर्स पाहिजे. तर नॉर्मली जे आपल्याकडे जी आपण एमएससीबी कडनं जी इलेक्ट्रिसिटी घेतो किंवा जी ग्रीड मधनं एनर्जी घेतो ती एसी सोर्स आहे. तर मग मार्केटमध्ये एसी टू डीसी चार्जर्स आहेत आणि काही व्हेकल्स मध्ये ऑनबोर्ड चार्जर्स आहेत. जे तुम्ही टेस्ला मोटर्स घेतला ना, तर त्यांच्या व्हेकलमध्ये ऑलरेडी चार्जर बसवलेलाच आहे. तर तुम्हाला फक्त एसी इनपुट द्यायचं आहे, तो एसी टू डीसी कन्वर्ट करतोय. सो दिस इज कॉल्ड एज ए टू डी कन्व्हर्टर्स. आणि मग तुमच्या रिस्पेक्टिव्ह व्हेकलला चार्जिंग होते. अगेन या चार्जिंग मध्ये वेगवेगळ्या टाईपचे चार्जेस अवेलेबल आहेत. म्हणजे काही 2 पिन, 3 पिन आणि काही बेसिकली कम्युनिकेशन कनेक्टर्स पण त्याच्यामध्ये अवेलेबल आहे. तर काय होतंय नॉर्मली चार्जिंगच्या केसेसमध्ये प्रत्येक कंट्री स्वतःचे स्टँडर्ड वापरते. म्हणजे चायनाने स्वतः इनिशिएट केलं, त्यामुळे चायनाचे स्वतःचे वेगळे चार्जेस असेल. इंडियाने लॅटर चालू केलं, त्याच्यामुळे आपल्याकडे दोघं तिघे शेप्स अवेलेबल आहेत. तुम्ही आज जर इंडियात कुठल्या तरी चार्जिंग स्टेशनवर गेले तर तुम्हाला दोघं तिकडे टाईपचे चार्जेस मिळणार. चादेमो म्हणून एक चार्जर आहे, जो जापानीज लोकांनी चालू केलेला आहे. आणि फास्ट चार्जर आणि स्लो चार्जर असे पण 2 टाइप्स आहेत. तुम्हाला फास्ट चार्जिंग पाहिजे असेल तर त्यासाठी वेगळं कॉस्ट आहे. स्लो चार्जिंग पाहिजे असेल तर त्यासाठी वेगळी कॉस्ट. डेफिनेटली फास्ट चार्जिंगसाठी तुम्हाला जास्त पैसे पे करावे लागतात आणि स्लो चार्जिंगसाठी कमी आहे. डिपेंड्स ऑन यू की तुमच्याकडे काय, किती वेळ अवेलेबल आहे आणि किती पैसा अवेलेबल आहे आणि किती तुम्ही पुट करू शकता. गॉट इट. तो नॉर्मली तुमचा क्वेश्चन हा होता ना की बाबा आउटपुट काय पाहिजे, तर डीसी व्होल्टेज पाहिजे. नॉर्मली तुमच्याकडे एसी असते ना, एसी टू डीसी कन्व्हर्टर्स चार्ज. नॉर्मली तुमचं जे पण काही चार्जेस आता अवेलेबल आहे ते सगळे चार्ज बेसिकली ए टू डी कन्व्हर्टर्स. त्यामध्ये एक छोटासा ट्रान्सफॉर्मर असतो, तो स्टेप डाऊन करतो आणि एक इलेक्ट्रॉनिक सर्किट असते की जे स्टेप डाऊन केलेला एसी करंटला डीसी मध्ये कन्वर्ट करते. ठीक आहे.
हो सर, ओके, थँक्यू.
एनी क्वेश्चन्स आर वेलकम. तुम्ही विचारा बेसिकली. कारण तुम्हाला खरं सांगतो, बिकॉज यू आर डिप्लोमा होल्डर्स, तुमच्याकडे खूप अवकाश आहे. पण तुम्ही चांगला बिझनेस स्टार्ट करू शकता याचा. आणि आता आम्ही बघतोय की आमच्या आरआयटीचे स्टुडंट सुद्धा आर्टिकल्स बनवत आहेत. डिप्लोमा स्टुडंट, डिप्लोमा फॅकल्टीज आर ऑल्सो इन्व्हॉल्व. आम्ही आता रिजनरेटिव्ह ब्रेकिंगवर काम करतोय. तसं तुम्ही एक प्रोजेक्ट घ्या, तुमच्या फॅकल्टीला इन्व्हॉल्व करा त्याच्यामध्ये. आणि स्टुडंट्स आणि फॅकल्टी मॅनेजमेंट असं थोडंसं एक चांगली इकोसिस्टम डेव्हलप करा. इंडस्ट्री पार्टनर्स घ्या. इंडस्ट्री तुम्हाला पैसे देते, म्हणजे इंडस्ट्री तुम्हाला स्पॉन्सरशिप देते, फक्त तुम्हाला टॅप करता आलं पाहिजे. तर हे सगळं पॉसिबल आहे. व्हॉट यू हॅव टू डू इज यू हॅव टू कम ॲट द फ्रंट लेवल. तुम्हाला पुढे यायला पाहिजे, है ना. आणि हे सगळं पॉसिबल आहे. हे ट्रान्सफॉर्मेशन जसं होईल ना, तसं बिझनेस अपॉर्च्युनिटी सुद्धा वाढत जाणार. खूप सारे अपॉर्च्युनिटी. म्हणजे तुम्ही जस्ट टेक्नॉलॉजी वाईज नाही बघितलं किंवा डेव्हलपर स्वतःला नाही बघितलं तरी सुद्धा तुम्ही इलेक्ट्रिक व्हेकल सेल्स मध्ये सुद्धा येऊ शकता. तुम्हाला जर चांगलं नॉलेज असेल ना इलेक्ट्रिक व्हेकल्स, फक्त नॉलेज आहे, बेसिक नॉलेज, की चार्जिंग कसं होतं, इलेक्ट्रिक व्हेकल्स काय, त्याचे ऍडव्हान्टेजेस काय, हे जर तुम्हाला माहिती असेल ना, आणि थोडं सेल्सचा बिझनेस तुम्हाला जर नॉलेज असेल तर तुम्ही सेल्स पण करू शकता. इलेक्ट्रिक बायसिकलचं सेल्स करू शकताय तुम्ही, 2 व्हीलरचा सेल्स करू शकताय, 3 व्हीलरचा सेल्स करू शकताय. हे सगळं पॉसिबल आहे. ठीक आहे ना. एनी अगेन क्वेश्चन्स?
अजून कोणाला जर क्वेश्चन विचारायचे असेल तर प्लीज.
यू मे सेंड मी
हॅलो सर.
मेसेज ऑल्सो. या प्लीज.
सर, आपण एकदा जर ईव्ही बाईकची बॅटरी चार्ज केलो तर मग ते
हा.
100 पूर्ण आपण युज करू शकतोय काय? म्हणजे ऍव्हरेज मध्ये काही असं कमी वगैरे होणार नाही?
नाही, आता नॉर्मली तुमची मोबाईलची बॅटरी असते बघा, ती पण लिथियम आयन बॅटरी असते. तुम्ही 100% चार्ज केल्यानंतर ग्रॅज्युअली रिड्यूस होते डिपेंडिंग अपॉन लोड. तुम्ही किती युजेस करताय बॅटरीचं त्याच्यावर डिपेंड करते. ॲज इलेक्ट्रिक व्हेकल इज कन्सर्न, तुम्ही किती फास्ट स्पीडने चाललाय ना त्याच्यावर डिपेंड करते की बॅटरी डिस्चार्ज कशी होते. तर त्याचा जो रेट आहे ना, हा तुमच्या लोडवर डिपेंड करतो की तुम्ही किती फास्ट चालवतायत. समजा हिली एरिया असेल तर डेफिनेटली इट विल ड्रेन इट फास्टर ना. तुमचा मोबाईल तुम्ही नॉर्मली युज करताय, तुम्ही जर युट्यूब चालवलं
हा,
किंवा
येस सर.
हा सॉरी, तर तुम्ही नॉर्मली समजा तुमच्या मोबाईलची बॅटरी कशी ड्रेन होते लवकर, जर तुम्ही व्हिडिओज बघितले जास्त तर तुमची मोबाईल बॅटरी ड्रेन होते. तसं ईव्हीच आहे, ईव्हीची बॅटरी ड्रेन लवकर होणार जर तुम्ही
सर प्लीज जरा अनम्यूट करा.
20% सॉरी, तुम्हाला ऐकू आलं सगळं उत्तर का परत रिपीट करूया?
नाही सर, रिपीट करा जरा प्लीज.
ओके, प्लीज रिपीट करू. ओके, तुमचा प्रश्न असा होता की 100% जर मी बॅटरी चार्ज केली असेल तर ती कुठल्या रेटने रेट डाऊन होणार? तर तो रेट डिपेंड करतोय तुमच्या लोडवर. तुमचं जर ग्रॅडेबिलिटी जास्त असेल, म्हणजे स्लोप जास्त असेल तुमच्या रोड प्रोफाईलचा, तर तुमची इलेक्ट्रिक व्हेकलची बॅटरी लवकर ड्रेन होणार. आणि इट ऑल्सो डिपेंड्स ऑन स्पीड. तर विथ व्हेरी हाय स्पीड तर तुमच्या व्हेकलचं अगेन रेट जास्त होणार, म्हणजे बॅटरी डिस्चार्ज रेट जास्त होणार. आणि सगळ्यात महत्वाचं तुम्हाला बघायला पाहिजे की 20%च्या आत कुठली बॅटरी डिस्चार्ज होता कामा नये. द रिझन बिईंग की जेवढं तुम्ही 0 पर्यंत जायचं ट्राय करणार 20% आतमध्ये, तेवढं बॅटरीची लाईफ कमी होते. अँड द रिझन बिईंग इज की बॅटरी तुम्ही बघितलं बॅटरी केमिस्ट्रीमध्ये तर इलेक्ट्रोड्स असतात आणि त्याच्यामध्ये एक बॅरियर असतो, इलेक्ट्रोलाइटचा एक बॅरियर असतो, तो डिस्ट्रॉय होण्याचा जास्तीत जास्त चान्सेस. त्यामुळे डोंट ड्रेन युअर बॅटरी बिलो 20%. ओके, सो आय होप यू आय आन्सर युअर क्वेश्चन.
Yes, sir.
येस येस.
अजून कोण क्वेश्चन विचारणार आहे?
सर
अजून कोण क्वेश्चन विचारणार तर प्लीज.
हॅलो
हा, प्लीज प्लीज
हा.
आस्क क्वेश्चन.
सर, इलेक्ट्रिक व्हेकलचा पिकअप डिझेल पेट्रोल इंजिन सारखा असणार का त्यापेक्षा कमी असणार?
जास्त जास्त असणार, कारण ते ग्राफ मध्ये मी तुम्हाला दाखवतो. हा ग्राफ बघ, या ग्राफ मध्ये दाखवतो की आयसी इंजिनचा जो टॉर्क आहे ना, तो स्पीड जसं वाढतो ना, तुझ्या इंजिनचा स्पीड वाढतो ना, तसं तसं हळूहळू वाढतो. ठीक आहे ना. पण इलेक्ट्रिक व्हेकल्स मध्ये स्टार्टिंगला टॉर्क कॉन्स्टंट असतो आणि नंतर तो रिड्यूस होतो. तुला इनिशियल टॉर्क नेहमी जास्त मिळणार इलेक्ट्रिक व्हेकल्स. दॅट्स वाय जी टेस्ला मोटर्स आली ना, ती स्पोर्ट्स व्हेकल का म्हणतात तिला, कारण की त्याचा इनिशियल टॉर्क चांगला आहे. आणि जेवढा इनिशियल टॉर्क चांगला तेवढं तुमचं ऍक्सिलरेशन चांगलं, जेवढं ऍक्सिलरेशन चांगलं तेवढं पिकअप. ठीक आहे. I hope I
Okay.
answered you. Right?
ओके, ठीक आहे. तर आजच्या या वेबिनार साठी रिसोर्स पर्सन म्हणून अवेलेबल असणारे RIT इस्लामपूरमध्ये कार्यरत असणारे प्रोफेसर LR पाटील सर हे वेळात वेळ काढून आपल्या वेबिनारला उपस्थित राहिले. त्यामुळे मी त्या पाटील सरांचं आपल्या सर्वांच्या वतीनं, आपल्या कॉलेजच्या वतीनं आभार मानतो. त्याचबरोबर पाटील सरांनी आपल्याला नीड ऑफ इलेक्ट्रिक व्हेकल, फिजिबिलिटी ऑफ इलेक्ट्रिक व्हेकल, त्याचबरोबर ड्राईव्ह ट्रेन फॉर इलेक्ट्रिक व्हेकल, नीड ऑफ ऍडिशनल स्किल्स फॉर इंजिनियर्स याबद्दल महत्वपूर्ण सर्व माहिती दिली. त्याचबरोबर व्हेरियस बिझनेस, जे काही इलेक्ट्रिकल व्हेकल मध्ये नवीन बिझनेस आपण करू शकतो, त्याचबरोबर नवीन नवीन जॉब ऑपॉर्च्युनिटी ज्या काही आपल्याला मिळू शकतात, याबद्दल सुद्धा त्यांनी महत्वपूर्ण माहिती दिली. त्याबद्दल मी पाटील सरांचं आपल्या सर्वांच्या वतीने आभार मानतो. त्याचबरोबर हा वेबिनार अरेंज करण्यासाठी महत्वाची भूमिका बजावणारे मेने सर आणि त्यांना प्रोत्साहन देणारे मेकॅनिकलचे HOD मोहिते सर यांचंही आभार मानतो. त्याचबरोबर या वेबिनारला परमिशन देणारे प्राचार्य दाभोळे सर आणि या वेबिनार अटेंड करण्यासाठी सर्व मुलांना प्रोत्साहित करणारे सर्व SGMR पॉलिटेक्निकचे टीचिंग स्टाफ, नॉन टीचिंग स्टाफ आणि हा वेबिनार अटेंड करणारे स्टुडंट्स, या सर्वांचं मी आभार मानतो. आणि सर्वांच्या परवानगीनं आजचा हा वेबिनार संपन्न झाला असं मी जाहीर करतो. थँक्यू व्हेरी मच.
थँक्यू सर, अपॉर्च्युनिटी दिल्याबद्दल. ऑलवेज वेलकम. कधी
थँक्यू सर.
ओके सर, थँक्यू सर, थँक्यू.
आणि अनुगटकर
ती कुठे होती तिच्या बरोबर त्याच्या बॉयफ्रेंडला भेटायला त्याला पाठव कुठे गेलेला तुम्ही जीव द्यायला चल जेव
हॅलो. हॅलो. I am single. I am single.